Welcome. We're here for the Iowa Ideas Environment Track for 2023. We're glad to have you here. Or welcome back if you've been attending other sessions. This session, like the other 50 plus of Iowa Ideas Conference, has closed captioning access and is being recorded for future posting online. Thank you also for sponsoring our conference, ITC Midwest. This session is titled Protecting Ourselves from Forever Chemicals. I'm Erin Jordan, I'm a Gazette reporter, and I'm your moderator. We have a great panel today who will introduce themselves in just a moment. And I have some questions, but I'd also like to include your questions in our conversation. So please feel free to submit those questions through the Whova app, and I will try to fit as many of them as I can into this conversation as we go along, rather than saving them till the end. So let's get started with introductions. Corey, do you want to start us off?
Sure. I'm Corey McQuaid. I'm with the Water Supply Operations with the Iowa Department of Natural Resources. I'm also the PFAS coordinator for the department. And welcome, everybody. Looking forward to the conference.
Darren, would you like to go?
Hi, yes, I'm Darren Thompson. I'm the Associate Director at the Center for Health Effects of Environmental Contamination at the University of Iowa. I'm an environmental epidemiologist.
Oh, okay. I think I said two of you at the same time, or two of you went at the same time. So Darren, you went, that was good. And now Galen, I've got Galen on the phone. So we're going to see if everyone can hear him. So go ahead, Galen.
Okay. My name is Galen Bayway. I'm the Public Works Director for the City of Command, Iowa. And about 28 years in wastewater and a couple years in water now. And we're extensively dealing with the PFAS right now.
Great. And last but not least, Joe.
Hi, I'm Joe Charbonnet. I'm an assistant professor of environmental engineering at Iowa State University. PFAS are one of the chemical contaminants that I study.
That's great. Well, thank you so much. So as you guys have gathered, what we're talking about today are per and polyfluoroalkyl substances, also known as PFAS. But what are PFAS? You know, it's maybe a confusing group of chemicals, and maybe even just a confusing word to say. So, Joe, you're the expert in aquatic chemistry. What exactly are PFAS?
Right, so PFAS are, and I'm glad you said are because PFAS are plural. PFAS are a group of chemicals, at least 9,000 chemicals in this group, probably many more. And these chemicals are all characterized by having a carbon-fluorine bond, a carbon and a fluorine atom bonded together. And that's the strongest form or bond in organic chemistry. And that strong bond is what gives them their chemical properties that make them so useful, and also what gives them a lot of their harmful properties, including their persistence, that strong bond between the carbon and the fluorine. And so there are a lot of acronyms that get thrown around to describe different PFAS chemicals, and you may not be familiar with all of those acronyms, and they might be really confusing to you, and that's okay, because they're confusing to chemists too. But you're probably familiar with some of the products that are made from PFAS, so things like Teflon and Gore-Tex and Scotchgard. Those are all PFAS and made from smaller PFAS all bonded together.
And just before we go on for that, so these products have been around for decades, right? These chemicals have been around for decades. And when they were developed, they were thought to be beneficial for a lot of products, right?
Yes, and they still are very, very beneficial for many of their intended uses. They work so well for a lot of the things that we use them for, which is part of why these chemicals are everywhere, because they work so well for so many different things. They repel both water and oil, which is a very, very odd property for a chemical to have. Most things are good at repelling either one or the other, but not both. So they're very useful for lots and lots of industrial and commercial and medical applications. So it's a shame that they're so toxic and persistent as well.
Yeah, and along that front, just since we're talking about the toxicity, Darren, you have this public health specialty. Could you tell us a little bit about PFAS and how they affect the human health if ingested?
Yeah, so there's several exposure routes, not just ingestion, but inhalation as well. So really, the kind of the primary concern is that they break down very slowly, and there's potential for them to build up in people and animals and the environment. Kind of the science related to how they affect health is kind of constantly evolving. Just as more comes out, more research is starting to be done. But some of the kind of preliminary things that we know or suspect based upon animal studies and epidemiological studies, decreased fertility in women, some studies showing up to 40% lower chance of becoming pregnant, increased high blood pressure, especially in women during pregnancy. One study showed 71% higher risk of developing high blood pressure based upon higher concentrations in blood serum. Various developmental effects and delays in children, including low birth weight, accelerated puberty, behavioral changes. In some cases, increased cancer risk, especially prostate, kidney, ovarian, testicular, and uterine cancers. Immunotoxicity, so PFOA and PFOS, so two types of these PFOS compounds have been shown to suppress the immune system. So especially people who have been vaccinated, suppressing the response so that the vaccines aren't as effective as it would be with people who have lower blood serum concentrations. Also, increased cholesterol levels and increased risk of obesity. And in some cases, there's been studies that showed higher PFOS levels promote weight gain and make it harder for people to lose weight when they're on a weight loss program.
A lot of different effects for the human body. So, Corey, from the DNR perspective, how and when did PFOS become a contaminant that the DNR was monitoring, and what's kind of happening on that front?
Well, when I first heard of PFAS, we did some sampling in the state of Iowa with what we call unregulated contaminant monitoring rule number 3. This was with EPA, but that was back in 2013 to 2015. But at that time, we did not detect any PFAS concentrations in the state, but we had different levels that we were detecting for. So we only went down to like 29 parts per trillion at that point in time. And so we didn't have any detections at that point. And so we thought from, a state perspective that we were sitting in pretty good shape. And then, I sat in on a presentation, from in 2018, and somebody says, well, you just haven't looked everywhere, and you haven't looked, the levels have dropped, that we can detect for now. And so it was really in about 2020 that we put together our PFAS action plan for the state of Iowa. And so that really has 3 parts that we utilize for our action plan. The first part is to sample, to identify and monitor where PFAS is at in the state. The second part was pollution prevention. What can we do with PFAS that is out there, like firefighting foam? The challenge with the pollution prevention is what do we do with it, and how do we get rid of it? That's still the challenge today, is the destruction options for PFAS. And then the third part was just education and outreach, which we developed our state of Iowa or department dashboard. So all the results and all the monitoring that the results we've collected throughout the state are put up on a map. People can click on their community if they're interested to see where we've tested and what those results are. And currently all of our results that we even have in our permits now for quarterly monitoring are also on our website there. So individuals can see what has been done in their community, if we've done any testing there or not. And, eventually we want to get all the way across the state of Iowa. But currently EPA is working on a new regulation which will help us get there. But at this point, we've sampled about 60% of the population, so all the large facilities across the state of Iowa. We have a number of small communities that we have not tested. And with EPA's new unregulated contaminant monitoring rule number 5, which just started this year, so they're sampling from 2023 through 2025, all communities 3,000 and above. And so we're now starting our focus on those smaller communities across the state. But we've sampled, by the time we get done with our sampling with EPA, the UCMR 5, and our own study, we'll have it covered at least 75% of the the state. And then a lot of the small communities that we haven't tested will get covered by the new proposed rule that EPA has out there. And then the last piece is the private wells, which we'll talk a little bit about today.
Yeah, that's great. That's a great overview of that program. Galen, I wanted to ask you, as the Public Works Director for the city of Comanche in eastern Iowa along the Mississippi River, can you tell us a little bit about how and when you and other Comanche officials learned about PFAS in the city's wells in which you are used for drinking water?
We officially started testing in January of 22 to get those results. My understanding is we had a couple previous tests before that showed a small amount there, but under the reportable limits or the issue limits by EPA. After January 22 test, they said, yep, we have it here at this level. The EPA has changed their numbers on that, and now we're above their issue number. Since we have 3 shallow wells, all 3 of the shallow wells had levels above 70 parts or around 70 parts per trillion. And so their deep well did not. So after that, we started working with 3M and EPA, and 3M got together and came up with agreement that, yes, they're probably responsible. And we started working that. So now we're testing quarterly on all of it. And actually, everybody within the 4-mile radius of their Cordova plant is even a private well gets tested for free just to see where the levels are at.
You mentioned 3M, which was the original manufacturer of a lot of these chemicals. And so they have a manufacturing plant very close to Comanche. You know, it's my understanding this was like a requirement, like a settlement with the EPA and 3M. Is that kind of how Comanche got this additional oversight?
Right. We call it the consent agreement.
Okay.
Basically, 3M said, yes, this was probably our and we're going to do everything we can. And they've been great to work with for us. They're in front. We have constant meetings with them, and they're giving us what we need to have better drinking water again.
That's great. And I feel like we're going to have other questions that we'll call on you to respond to, because you guys have been dealing with this firsthand with your drinking water source. So I wanted to just ask the group, and I'm not sure who wants to field this one, but how exactly do PFAS get into drinking water, and how do we trace its source? In this case, as Galen said, 3M has taken some ownership of that, but how do we kind of trace that back through drinking water?
There are 2 main ways that PFAS really get a lot of attention for getting into drinking water. The first is associated with manufacturing. So in places where they manufacture the PFAS themselves, or products that are made out of PFAS, oftentimes those factories will emit PFAS into the environment. The other really big high-profile source that gets a lot of attention is from their use in firefighting foam. PFAS are really effective at putting out jet fuel fires, and so a lot of fire training activities, especially on military bases where they practice putting out jet fuel fires all the time, have resulted in enormous amounts of PFAS-containing firefighting foam being applied to these fire training sites. And so those are the 2 biggest, most high-profile ways that PFAS can get into water supplies. There are other ways too. Certainly the land application of wastewater solids has been implicated in some cases. Certain additives to certain components like pulp and paper processing and power generation equipment have been implicated as well. But certainly manufacturing of the chemicals themselves and firefighting foam use are the 2 most high-profile ways that it gets into our water.
And, with regard to the firefighting foam, we've reported in eastern Iowa just about the eastern Iowa airport doing a site assessment because of some PFAS found in wells around the airport. Corey, I don't know if you would speak to, obviously the eastern Iowa airport isn't the only place where this is happening. There's many airports and military bases across the country that are dealing with this, but just how the DNR is kind of overseeing a site assessment at a place like the airport, the Eastern Iowa Airport?
Right, and as you mentioned, some of the military installations, and that's kind of how we first started, that's why one of the reasons we put our action plan together was because of the Air National Guard facilities in the state. DOD had done a study and had done some sampling at both Sioux City and Des Moines and had some levels there. So that's really how we first started down the PFAS road. And the reason we did our action plan was to get a better idea of what's across the state. And then, so those two facilities are, of course, have, utilized firefighting foam at these installations. And then we, started looking at other airports as well. And so I believe Cheek was one of the first to sample maybe some wells outside of the airport in Cedar Rapids. And I think Darren could maybe talk to that a little bit more. So that's kind of how we discovered the, PFAS in that particular area. And then our contaminated sites section, which I'm not an expert in contaminated sites, has been looking at this and is working with the airport there in Cedar Rapids to continue to investigate where the contamination is coming from, because there's not only firefighting training foam or firefighting foam that was utilized there. There's also some biosolids applications that's also been used in and around the land around the airport as well. So they're taking, it's a slow process to do these site assessments, and it takes a lot of time. For our sampling that we did for drinking water, we're just looking at what's in the drinking water. There has been one other facility that we've taken a harder look at to see where it has potentially come from. But that takes a lot more time, resources, and effort to try to identify where it's actually coming from. Our concern is just what can we do immediately to identify what's in the drinking water and to reduce those levels as much as we can, which has been a great effort across the state. With the communities have done what they can, to take a well off a line, to blend the water so they can get the PFAS concentrations as low as they can until we get a final rule from EPA where we can install treatment across the state.
Yeah, that's great. I guess I would ask Darren if you could talk a little bit about what the Center for Health Effects of Environmental Contamination at the University of Iowa has been doing with, PFAS testing and other things.
Yeah, so this all kind of started for us around 2019, 2020, when we were working with the U.S. Geological Survey. Initially we did a kind of a reconnaissance of streams across the state, and there we found detection of at least one PFAS substance in 32% of the samples, but all at fairly low levels. And with that, we calculated what's called the exposure activity ratio, and this is essentially where we're taking the concentration that we find in the environment, concentration of what is kind of been shown to cause biological activity at the molecular level in vitro, and calculating a ratio. And so typically, if it's above 1.01, it would be kind of a level of concern. And none of the detections that we found at that time were exceeding that level. So they're all relatively low. That followed that up. We've been doing some private well testing and some follow-up surface water testing, not just around the airport in Eastern Iowa, but throughout the state. So we currently have a study where we're looking at levels in other surface waters across the state, and then looking at private wells in Western Iowa, Eastern Iowa, and Central Iowa, and those studies are ongoing. So I think our focus is really private wells and surface water. Private wells especially being vulnerable, and that it's typically comes down to the well owner being responsible for the quality of their water. And so we're trying to better understand what is present in wells across the state.
Okay, just a question from our audience that maybe I'm not sure who's the best person to field this, but it says, could you briefly explain biological half-life, and should we fear all PFAS if some pass through rather quickly?
That's a good question. So this idea of biological half-life is I have a certain amount of PFAS in my body, how long does it take for half of it to be excreted out of my body? And we find that the half-lives of PFAS in general tend to be much longer than other contaminants. That's because they're bioaccumulative. They build up in the food chain. They tend to stick around in our bodies. They want to stick to our proteins. So they tend to be more persistent in our bodies as well. But there's a wide range of biological half-lives of persistence in our body that these chemicals have. And the longer that carbon fluorine chain is, the longer they persist in our body. So a lot of the newer PFAS that are being manufactured now to replace some of the legacy compounds that we've known are harmful for longer are shorter chains and do have shorter half-lives within our body. That said, it's sort of 6 of one, half dozen of the other, I think, because those chemicals also tend to be more mobile in the environment and tend to be taken up into our food supply more readily. They tend to get into crops, they tend to get into animals, and then they tend to get to us more readily. And so they just cycle through the environment, including humans, faster than perhaps these legacy compounds do. And I'm not entirely sure if that's better.
Thank you for that, for making that understandable. And when I heard biological half-life, I thought, oh no, this is gonna be complicated, but that makes a lot of sense. So, you know, we want to touch on, of course, spend some time on private wells, because as Darren and Corey have both mentioned about the importance there. So about 7% or 230,000 Iowans get their drinking water from private wells. What do private well owners do to find out if their wells have, you know, potentially dangerous levels of PFAS?
Well, one thing I can say is, you know, with the sampling that we've done around the state, and I forgot to mention, you know, we kind of looked at, you know, potential PFAS users, you know, based on industrial classification codes or manufacturing facilities that had the likelihood that they may use PFAS. And we don't have, you know, verification that they do use PFAS. So we took a list of 1,200 facilities around the state, and then we looked at the communities and how close their wells were located to these facilities, and then what the depth of their well is or their susceptibility was. And so that's kind of how we started our monitoring approach. We looked at the worst case scenarios first, and then kind of went out whether it was distance or depth of wells based on that. And so, you know, based on the information that we have on our dashboard, you know, somebody can go out there and look and say, hey, is there any other contamination in the area that I live? You know, and then if you're close to that community or live right outside town, or you're close to an industrial facility, you know, you may want to get your private well tested. There are options available through the Grants to Counties program that we work with in coordination with the Iowa Department of Public Health. They have funds available that can be given to the county sanitarians to conduct this sampling or for testing for PFAS. And so we have 12 counties right now that have been approved for PFAS testing. So if you're in one of those communities, you can talk to your local sanitarian to see if they're not approved. You can even ask them, hey, can you get approval to do that? I have concerns about my own well, because it shows on the DNR map that they've found PFAS in an area that's close. So, you know, if you have a good reason to justify that, and these tests are expensive, and so that's one of the large challenges. You know, with somebody that's living in a rural community, you know, we're not going to have a concern. You know, depending on where they're located. Now, if they're in close to some of these potential sites, then they may have a concern. So they would reach out to their local sanitarian to request the funding from the Grants to Counties program to get their well tested.
And, you know, as you mentioned the cost, and we were speaking about that just before we jumped online, you know, it sounds like it's pretty expensive to do this testing because of the process and the equipment involved in the very low levels of PFAS it takes to potentially cause a health risk. But Darren, is the University of Iowa trying to do some work to develop maybe some different testing opportunities?
So yeah, Cheek has started a lab, and we have been doing some limited testing, specifically in kind of areas where we have our research studies going. I know the State Hygienic Lab has developed methods to test for PFAS in water, and there are also private labs. I think, but from Cheek's perspective, eventually we'd like to get to the point where we could open it up to more people. We're not at that stage, being a very small center with limited resources. But the goal is to eventually get to the point where we'd be able to make it more available at a more cost-effective price for the average Iowan.
Just turning back to Comanche, Galen Payway, the Public Works Director. So, with the steps you've had to take there to try to, remove PFAS from the drinking water supply, would that have been within the city's budget to cover that if 3M hadn't come in to kind of help out financially?
Probably not. What we're actually doing is they're funding the digging of 2 new deep wells for us. We have three shallow wells that were all had tested high for PFAS, and our shallow well, or our deep well at 1,200 feet was PFAS free. So the plan is to dig 2 more 1,200-foot wells around town. We're waiting on final confirmation from the DNR and EPA for the spots and that such. Then that water should all be PFAS free. But yeah, those are not cheap. So those are very expensive. The drilling of the hole, all the equipment, new building, electrical, piping into the current network of pipes in the city. It's a very large dollar undertaking. So yeah, without them coming in and going, yep, here's our checkbook. Sorry for your old wells. Here's the new one for you. It would be very difficult.
What's a ballpark for a new well, a new city well?
We're looking, I believe, 200,000 to 300,000 feet, wow. And that's low end. If everything goes perfectly well, probably pushing up for our entire project. Or our engineer company is estimating 2 to 3 million all in. With that. Just the hole in the ground is close to 200,000. The pump itself we're putting in the ground is 178,000. I think the one you just ordered.
Okay. Now you mentioned deep and shallow wells. Just would put out to you and to others on the panel, is it thought that PFAS are more prevalent at shallower levels underground?
Yes, they've only gone. I think the deepest we tested at was about 300-foot well, and it is there. And Comanche is maybe a little unique to some other cities in the state. And we have a lot of what are called fan point wells. So you can go right next to the river. So you can literally go punch 20 to 30 to 50 feet of pipe in your backyard, put a pump in there, and you can pull out shallow water. That we tested several houses that have those pumps fill your pool or water your lawn, things like that. What people use them for. And we tested several of those, and there's detectable levels, high levels in that well, and all the way down to 300 of our shallow well. And so we know it's there, but it's not down at 1,200 feet. So 3M has also come in and says, hey, anybody that has still within city limits and within the 3 to 4 mile radius, if you have a well, so kind of out in the country, if you have a well, we'll come and test it for you if you're within this radius. And if it's high, we will put a filtration system in the house for you, and we will monitor it for up to 5 years, including filters and doing it. So they're even doing that to people outside of the city limits who have their own wells. So the Brilliant has really stepped up in our area, and we're happy to be working with them on that.
Great. Just turning to the panel, is there anything you would add just about why PFAS may be found at certain levels underground but not others?
Yeah, so PFAS have this really interesting chemical property. They're what's called surfactants, surface active agents. They're like soap. You have surfactants in your kitchen right now if you have soap there. And they do a really good job of sticking to surfaces. They want to be at the interface between two different things, between water and air, or between water and minerals. And so as they enter the soil, they really want to stick to places where there's a lot of surface area of air and water meeting each other. And so as you get deeper and deeper and you fill up all of the pore spaces in between the little particles of dirt and soil, you get less of those interfaces that the PFAS really like to stick to. So, I think it's probably true for most chemicals and most contaminants that they tend to be more abundant closer to the source of their contamination, which is typically the surface. But that's especially true with PFAS because of their strong surfactant characteristic.
That's so interesting. Is there any risk, I guess, like say you are digging a new well and there might be some surface level contamination that's there, is there any concern that as you drill down through those more contaminated layers that may draw contamination down to a lower level? Does that make sense?
I would say yes. I mean that is the
Hold on,
case. Go ahead.
Corey. Just can you guys hear Galen? All right. So. Okay. Galen, go ahead and say what you're going to say, and then we'll have Corey add on to that.
Pretty good question, and I have not heard that concern before. Even talking with our the well drillers that we're looking at using, they don't think that will be a concern. That was never brought up. But yeah, that's a great question. I can ask them more on that.
Okay, Corey, what were you going to say to add to that?
But I just know in general, when I talk with our contaminated sites folks, we're always concerned when we have to drill through plumes of any type of contamination. So I would say that's always a concern in general for any type of contamination. And so there's, certain areas where they'll cap, a contaminated area, which means, you could be potentially putting a parking lot over it or something like that. So to help, shed water as well. So there's a number of different things they can do, but yes, that is always a concern of punching holes through contaminated areas.
Okay, so that's something to be mindful of too with this conversation. One thing I wanted to talk about too is just what homeowners can do. Galen had mentioned some of the things happening around Comanche with filtration. What are the filtration methods that are available for private well owners that when they find out they do have PFAS in their wells, and how much they cost and that kind of thing? Darren,
Well,
would you? Oh, go ahead.
I can go from a public water supply perspective, and some of this applies to other things as well. So when we look at water treatment for a community, there's 3 different types of treatment. So you have your granulated activated carbon, you have your ion exchange, and then you have your reverse osmosis. And the cost depends, and it all depends on the situation and the treatment plants, and they're set up as to what options are best for any community. And they'll have engineers or consultants that will kind of work with the community to see what options are best for them, and then they'll submit usually what we call a preliminary engineering report to take a look at what are the best options and costs for those facilities. And so some of those can kind of apply as well for a private well as well. And I think Darren might have done some of this work with Cheek as well, and so Joe and Darren can jump in as well.
Yeah, so a few of the people that we've worked with in testing their wells where we did find contamination, we provided reverse osmosis systems. And with those, we've tested obviously beforehand and then after. And we found that typically the reverse osmosis systems were very effective at removing PFAS. I know some activated carbon has been recommended, but I think with that, it tends to be not as much of a sure thing compared to reverse osmosis. And I think activated carbon tends to be, the quality varies, and some of the things we've looked at is, initially they provide very good protection. Then over time, they start to degrade and they need to be replaced fairly regularly. But reverse osmosis is what we've typically recommended. I
How
think the
much are you
prices
looking at?
vary. I think they're around $1,200, but that included the installation as well.
And the charcoal type filters, what are those costing?
I mean, those can be, tens of dollars to hundreds of dollars, depending on the system. I mean, like a typical Brita system is using activated carbon. A lot of refrigerators that you're able to get drinks from would have activated carbon filter. I have one on mine, and I want to say it was $30, $40 to replace.
Okay. So not as expensive as digging a new well, but obviously still a cost and something that people may not have budgeted to know how to deal with that. Is there any funding available for that sort of ongoing cost of filtration?
To my knowledge, there's nothing like that for, like a private homeowner that would be purchasing a system. It would be 100% on them to fund that cost.
Yeah, I
Okay.
would say, yeah. I mean, there is like the funding I talked about for the testing, but nothing for remediation or installation of treatment on the private well side. But as far as the community water supplies go, there is bipartisan infrastructure funding available. We have $12 million a year for PFAS specifically over the next 5 years to help communities that do need to do some type of treatment for PFAS, and that could be a new well. That could be, the treatment options that I've discussed, or it could be connection to another water supply or rural water, for example. So there's a number of different options for communities to consider. But the good news is we do have funding over the next 5 years for PFAS specifically, and then we do have a loan fund for communities as well for the state revolving fund to put in infrastructure projects around the state.
You mentioned that dollar amount. Was that 12 million?
Yeah, 12
Is
million
that just
specifically
for
for
Iowa?
PFAS. Yeah, just for Iowa. Yep, for the next
Okay.
five years, and then we do have other funding sources available as well. And then you have CDBG Community Development Block Grant or the USDA Rural Development Funding are also other sources of funding for drinking water infrastructure projects in the state of Iowa. So there's a number of different options for communities to consider. And so, they just have to take a look at what works best for them and what they have available.
Corey, are you aware of any larger communities that are dealing with this, having to, maybe change or mix up their water treatment process because of PFAS?
Right. So, one of the highest levels that we saw in the state was in Central City. And so, what the community did was take one of their wells offline and is relying on their other well. And so, they have recently submitted a project for a new well in the community utilizing this funding that I just spoke of. And so, they're currently in the works right now. They're on our intended use plan for the state to get funding from our state revolving fund to put in a new well. There are other communities at this point. Most of the communities are considering new wells because EPA has not finalized the PFAS regulation. They have a proposed national primary drinking water regulation that they put out in March of this year and hope to finalize it by the end of this year. Once we have that final standard in place, what we call the maximum contaminant level, then communities can start to design or plan on how best they can treat for PFAS. You can't really design a plant to treat for PFAS when you don't know what the final number is going to be. So hopefully by the end of the year, EPA will finalize this new national primary drinking water regulation for PFAS. Then communities can also look at installing treatment. But right now they're just looking at new wells or a new source of water or connecting to another water source. So Comanche is one of the first communities in the state to move down that road.
So I believe that the standard that's being considered is four parts per trillion is per liter of water. Is that
Yeah, so
right?
for PFOA and PFOS, 4 parts per trillion is what EPA is looking at for those two contaminants. There's also a hazard index, which is a new terminology for us where they have 4 other PFAS compounds that they're looking at. And PFBS, there's Gen X, PFNA, and PFHXS. So lots of, it's kind of alphabet soup, but they're utilizing a hazard index level. And if it's a lot of details, but there's this health-based water concentration. And one of them is at 2,000 nanograms per liter. Two of them are at 10 and one's at 9. So it's a combination of those four. If they exceed this hazard index of 1 with any of those four, or for example, if they're over 2,000 for PFBS itself, that automatically means they're going to be subject to this new rulemaking. So there's going to be 6 different compounds that EPA is working on that they're going to be finalizing here before the end of the year.
So given those preliminary recommendations from the EPA, how many communities do you think that will really make them mix up or, change what they're doing, or maybe have to dig new wells or other things?
So we have currently 7 communities that are required to do public notification. So that means they're above this proposed MCL at this point. And we have about 22 across the state that are doing quarterly monitoring. That means we've had an amount that we've detected. Doesn't necessarily mean they're above the proposed limit, but we want to see are the numbers increasing, decreasing, or staying the same. So we're just trying to get more information at this point to determine where they're at and what changes are occurring. This will give us a better idea when the final rule does come out, that whether they're going to be subject to it or not.
Okay, so question from the audience. They say there's so many different chemicals in the PFAS family. If there's talk of, removing 4 or some are prohibited and that kind of thing, sounds good. But when there's so many other chemicals, is that really meaningful change? I don't know, Joe, what you would say to that.
Yeah, that's a great question. Increasingly, there's growing scientific consensus that we ought to be regulating these chemicals as a class rather than one chemical at a time. What we're seeing happening with PFAS is the same thing we've seen happen actually with many other types of harmful chemicals, where we look at a particular individual chemical, we say, oh, this is harmful. There's a regulation or an industry shift, and they say, okay, we're going to go away from that. And they switch to another chemical that's very, very, very similar in structure. And this is what we call regrettable substitution. And these regrettable substitutions also often just mean substituting something for something else that is comparably harmful, but hasn't been proven to be that yet. And so, as scientists, we study what we call structure reactivity relationships. And this is a complicated way of saying things that look the same tend to behave the same way. We can kind of make those conclusions as chemists. And so because there is this common structural element to all PFAS, we can say that most PFAS are going to behave very comparably to each other. They're probably going to have similar toxic effects. They're probably going to have similar persistence and bioaccumulation because they all kind of look the same. And so there's a lot of scientific agreement, at least, that this one-at-a-time approach to regulating this class of thousands and thousands of chemicals doesn't really make a whole lot of sense.
So I talked to, oh yeah, go ahead, Galen. Yeah.
Corey was talking about the parts per million, parts per trillion. And one of you guys can correct me if I'm wrong, but we've been using the analogy to an average person what that is. If you took an Olympic-sized swimming pool full of water and put one eyedropper of a chemical in there, that's approximately 1 part per trillion. So that's the magnitude of the smallness that we're measuring down to. And like I said, people start talking about trillions and, it's almost like government spending. You can't fathom it. So that kind of puts it into a general perspective. Could anybody correct me if that's in wrong math?
Yeah, I've heard that also before as a way to kind of imagine it, the magnitude there. But and just as you mentioned, I'm really glad we're not talking about the national debt today. This almost seems less complicated than that. But no, that's a really good point. And that brings me to another statement. I was interviewing some folks near Swisher, which is in northern Johnson County, and they've some PFAS has been found in some private wells there. All of the residents in Swisher are on private wells. And she said, you know, I'm not that worried about it. I can't worry about everything. You know, we hear news reports about different health effects from a lot of different chemicals or things in our worlds. I don't know, Darren, if you would speak to, from a public health perspective, when you hear that sort of idea, you know, how do you respond to that?
Well, it's difficult because I hear that for other studies we've been doing as well related to pesticides and nitrate and things like that. And I mean, to a certain extent, I think it makes sense because it's kind of that self-preservation and kind of prioritizing where you place your concern. As a researcher, though, I think more research needs to be done to really kind of quantify what the effects are of this class in general. I mean, a lot of what we know is based upon kind of these handful of chemicals like PFOA and PFOS. I mean, a lot of the health studies are really based upon those, but as Joe mentioned, there's 9,000 in the class, and so a lot of that aren't in most analytical methods that you're going to test when you're looking at water. You're looking at blood serum. You may at a maximum. I think the highest I've seen is 47 compounds. So there's still a lot of unknown. And I imagine over the next 10 years, we're going to be able to kind of better, I guess, define what this exposure means on a broader scale. But as you know, for me personally, I'd be concerned. I've tested my water. I plan to continue to test my water. I'm on city water here in Iowa City. Haven't detected it, but it's something that I'm not going to lose too much sleep on, but I will be aware of and kind of make decisions to avoid the exposure for me and my family.
Yeah, and I think another thing that it really comes down to is choice and consent. And we all have risks that we take in our lives. Everyone that smokes knows that smoking is bad for them, and you can choose whether you want to take that risk or not. I know that drinking alcohol is not good, and yet I might go home and have a beer tonight because, that's a risk that I have chosen to take. I'm consenting to that. Water is such an intimate and personal thing. And I think that it's also a right. Everyone deserves to have clean water. And if you want to have that option, you should be able to have that. And it's not the sort of thing that you should have to worry about. So, I can understand if you're aware that it's there and you want to choose to take that risk, that's fine. But there's a lot of people that aren't aware of this problem and aren't consenting to being exposed to these chemicals. And it's coming into their houses through their taps in a very intimate way. And, I don't want to scare folks. The quality of our water in Iowa and across this country is really, really good. And you can depend on the water coming out of your tap. But, we need to be able to make that choice in an informed way. I think that's a right that we have.
Yeah, that's a good point. So wanted to talk a little bit about whether the landscape is shifting. Joe, you mentioned just there's some new types of chemicals being produced that have the shorter fluorine chains that may be good, may not be good. Are you seeing, I think one thing I thought was progress is I had read that the Eastern Iowa Airport is authorizing its director to spend money on new PFAS-free firefighting foam. And they've kept theirs in a very secure way in recent decades, so it hasn't been as much of a concern in recent years, but so they are going to move forward with that. So there's a new PFAS-free firefighting foams that have been approved by the Department of Defense. So there are some movements there, and I just didn't know if there were any shifts on this in manufacturing that anyone would point to.
Yeah, I mean, I think we are seeing lots of awareness around PFAS, and that's resulting in some shifts, both from the chemical manufacturers that actually make PFAS, but also largely from the downstream users. So, you look at outdoor companies that make waterproof rain jackets and things like that. And that's a place where you really want to have repellency of water, but also dirt and things like that. And they would just pick products off the shelf to provide that level of performance for a long time. But as we saw increased awareness about PFAS, we started to see companies in that industry say, we're going to choose alternatives that don't have PFAS. Same thing with carpets. Carpet coatings used to be high in PFAS, and now the entire carpet industry has decided as an industry, none of us are going to use PFAS in our carpet coatings anymore. Food packaging, there was a lot of high profile news stories about PFAS in food packaging. And increasingly, the people that make food packaging are saying, you know what, there are alternatives available to us that don't contain PFAS. So we're going to pick those instead to get the level of performance that we want.
And when we talked before this panel, you had mentioned just kind of picking and choosing products where it's really vital to have that versus products where, why do we even need that?
Sure. Yeah. There's this idea of essential use, and some uses of PFAS, I think, are actually essential. You think about medical applications, stents that go into people's blood vessels and things like that, where you really, really need a high level of performance. And maybe it is essential to have that level of performance that perhaps you could only get from PFAS in that application. But, if I'm going swimming, I expect to get wet. So I don't know why there are PFAS coated on my board shorts, because I'm going to get wet anywhere. I don't need waterproof swim trunks, that's not something that we should expect as consumers. And so just getting away from PFAS in those non-essential applications would be really nice.
So a question here from the audience. This is kind of shifting back to something that had been mentioned earlier, just talking about putting, they're often called biosolids, but it's essentially human waste from wastewater treatment plants, putting that on farmland. Is that happening less because of the risk of PFAS now? I don't know if any of you have a sense of to what degree biosolids are being applied and if that's contributing to this PFAS problem.
Well, I'll just say a little bit, there's been some studies, Maine, I think, has done a lot of work in this area specifically. That's a big challenge, and I don't think it's really been addressed across the country. I mean, because even if you start landfilling this, there's not going to be enough landfill capacity in the country to landfill the waste from a wastewater treatment plant. So that's a challenge, when they talk about destruction options and treatment, what can be done. There's tons of work being done on studying that at this point, and I don't think there's a great solution to that. And so I think that's still an unknown, and EPA is doing a ton of research in a lot of different areas, and that's one of them that EPA is continuing to work on, is what are some of the options for biosolids or land application from wastewater treatment plants. So I think that's a big unknown still at this point.
And Galen, you were going to add something?
We've got a seminar where they're discussing that, and twofold problem. Test it in the biosolids if you haven't come up with a good way to test it reliably. Then secondarily, if they do decide, hey, we need to not put this on farm fields because they don't know if it would be like uptake or animal uptake, concentrate it all in landfills, which is pretty much the only other option. Now you get super concentrated this, and the leachate coming out of the landfill would be 100 times higher than what was going in and concentrated. So you just move the problem over to this spot, then you're gonna have to clean it again.
Yeah, that's I could see that being kind of a problem either way. Just in terms of removing PFAS from water, I know I've done some coverage of the follow-up of that explosion in Marengo, where the firefighting foam contributed to a bunch of the runoff from that fire having PFAS in it. And I believe the state spent in the order of $800,000 to remove that from a very large retention basin before that water would go into the Iowa River. You know, that was maybe a unique situation, but are there means to remove PFAS from water in large scale? Is there progress happening in that way?
Well, no, and so we did, yeah, we had some involvement with the Marengo and the stormwater runoff that came from that fire. And so, yeah, we reached out to a contractor. You know, the good news is there's options to treat large scale waste or stormwater in those situations. And so they came in and I think they removed maybe 13 million gallons from that retention basin so that they could discharge that in the river. So, you know, the folks in Iowa City weren't pulling that into their treatment plant. You know, that was an unusual situation, and we were able to do that, but that's going to be difficult to do in every situation. So, you know, one thing we've done, you know, in working with our drinking water facilities around the state is encourage those drinking water plant managers to reach out to their local fire department and see what they have on hand so that they know, like, hey, if you're going to be using this, I mean, there's no laws against using the existing stuff at this point. There is new stuff out there, but it doesn't mean they don't have some old stuff back in the back room somewhere. And so there is still some of the old stuff that is out there and can be utilized if need be for real world situations. But the water plant managers or operators really need to know what's out there in their own communities, because if they do use it and it's in a location that is close to their wells, that's going to be a huge concern and a very costly a potential costly effect from the use of that. I mean, it could take the well offline for that community. So I've encouraged a lot of these communities to reach out to see what's still out there. But it's, I forget what your original question was on that.
No, that's super interesting. And because you could be potentially trading one expense of buying new firefighting foam for a more costly expense.
Yeah.
And that firefighting foam isn't used for every sort of fire. It's just kind of for those fuel-based fires.
That's correct. Yeah, they're what they call Class B firefighting foams.
Okay. Because because those chemical properties really help smother those oil fires.
Precisely. See, look at that, Aaron, you're going to be a chemist by the end of this.
I'm like thinking about you talking about the surface area and the air. Yeah, okay. Well, we're almost done here. I guess I just, you know, are there any other final words from our panelists? Anything else that I didn't ask about that you'd like to say?
I'll just say one thing, you know, I talked about EPA's final rule for drinking water, and they have a strategic roadmap. And so they're working, I mentioned it just a little bit, they're working a lot of different areas related to their strategic roadmap and on how best they can control PFAS and the contamination. And so there's still a long ways to go, and you know there's lots of methods, and you know the drinking water, there's 2 methods for drinking water that have been approved. There's other methods that EPA is still working on finalizing, so we have a long road to go yet for PFAS, but the good news is we are making progress.
Well, that's great. Go ahead.
Oh, and maybe if I could add, you know, one parting word, I think Darren exactly was correct with this idea that it's something that we should be concerned about and aware of, but I also want folks to trust in our public infrastructure and our public water supplies. They are really good, and you know, folks like Corey are doing a great job to make sure that we stay in this enviable position of having some of the world's best water coming out of our taps. And so it's definitely something to be aware of, but probably most folks don't need to panic about PFAS.
Well, thank you so much to our panelists. We have Corey McCoy with the Iowa DNR, Darren Thompson of the University of Iowa, Joe Charbonnet of Iowa State University, and Galen Payaway, Comanche Public Works Director. Thank you also to our sponsor, ITC Midwest. The next session in the Energy and Environment track is tomorrow morning at 8:35 a.m., bright and early. And that's about making progress on conservation practices in agriculture. I'm the moderator for that one too, and it's going to be super interesting. So thanks again to our panelists, and thanks to everyone for joining us today.